Let's look at solving quadratic equations and inequalities. So first of all, a quadratic equation, if you recall, is one that has that x squared variable appearing in there, and that's the highest power of on the x that appears in the equation. So when I have something like this equals 0, that's a quadratic equation. This is in standard form. Now, if we look at the zeros of that quadratic equation, my zeros are where the equation equals 0, so I would solve it by equaling it to 0. The x-intercepts are where the y equals 0, so again, I would set this side of the equation to 0. So all of these are the same as the solution set to where it equals 0. So whether I use the term find the zeros, find the x-intercepts, or find the solution set, I'm referring to the same thing. Solve this equation where it equals 0. So one way to solve a quadratic equation is using factoring. So if two things are multiplying to give me to 0, the only way that can happen is if one of the two things equal 0. All right, for example here, if I'm looking to solve this equation, the first thing that I might do is say, notice I have 3x squared, 6, and 9. All of those have a 3 in common. So I can factor out a negative 3 first. Negative 3 factored out of x squared would leave an x squared. Negative 3 factored out of the 6x would be a minus 2x. And then negative 3 factored out of here would be a minus 3. Now, looking at this, trying to factor this equation, I'm looking at the factors of this that will subtract to make a 3 in the middle. Well, the only factors of 3 are 3 and 1. So I know I have two factors. One is a 3, one is a 1. So to get a minus 2 as the result, I need the 3 to be negative, and then I'd have a plus 1 there. So now, setting each factor equal to 0, negative 3 does not equal 0. Equivalently, I could have divided the negative 3 to the other side. But setting this factor equal to 0, x minus 3 equals 0, and x plus 1 equals 0. X plus 1 equals 0. Solving each one of those gives me the solution set. X equals 3, and x equals negative 1. So my two solutions are at 3 and negative 1. Or equivalently, those are the zeros of the function. Now, what do I mean by those are the zeros of the function? I can find them on my graphing calculator. If I pull up my graphing calculator and I go to y equals, and I type in that equation, negative 3x squared plus 6x plus 9, and I graph that equation, it looks something like this. And these two zeros should match the zeros that I found. Now to find them exactly, you can hit second and the trace key to bring up the calc menu. And your option 2 is the 0. So the first thing it asks you is for a lower bound. So we want to move to the left of the first 0. Hit enter to mark the lower bound. And then the right bound, move to the right of 0. And then give it a guess to start calculating, and it tells you that that 0 is at negative 1. And then I would repeat that process again, putting the left bound over here and the right bound over here to find the second 0. And we see that that matches what we found here, the negative 1 and the 3. Now, let's find all the zeros of the quadratic function that's here. So now, again, I'm looking at the factors of 16 that will add to 8. Well, 4 and 4 add to 8. So this will factor into x plus 4 times x plus 4, or equivalently x plus 4 squared. So again, setting that equal to 0, x plus 4 squared equals 0, I could square root both sides and I'd get x plus 4 equals plus or minus the square root of 0 is still just 0. Subtract 4 from each side and we get x equals negative 4 as our only solution. Now in this case, we have the repeated solution, x equals negative 4. We also say it's a 0 of multiplicity 2. And we'll talk more about that coming up, the multiplicity of a 0. But basically, however many times the factor repeats here, the exponent would be the multiplicity of the 0. Now, when I have something squared equals 0, as in this previous example here, I had this equals 0. Notice I took the square root of both sides to solve the equation. So I could do that with any number. Take the square root of both sides equals 0. Take the square root of both sides of the equation, and I'd have x equals plus or minus the square root of the k. So I'll have two solutions if k is a real number. So if k is a real number, I'll have two solutions. If k is 0, then it'll only be one solution. And if k is a negative number, then I'll have no real solutions because I'll get an imaginary value. All right, for example, here, I want to solve this equation. So the first thing that I would do is get the x squared by itself. So I'm going to divide by -3 on both sides. So I get x squared is equal to a -6. And then square root both sides. So x would be equal to plus or minus the square root of -6. Well, we know that the square root of -1, we can take out an I and the imaginary unit. So I would have plus or minus I times the square root of 6 as my two solutions. Let's solve over here. The first thing I'm going to do is divide by 5. So I'd have x plus 3 squared equals, okay, that's going to be 18. Now square root both sides, and I'd have x plus 3 equals plus or minus the square root of 18. Now we know that square root of 18 is the same thing, that's twice 9, and 9 is perfect square, so I can take it out as a 3. So I'd have x plus 3 equals plus or minus 3 root 2 when I simplify square root of 18. Now subtract 3 from both sides. These are not like terms, so I can't combine them, so the -3 comes in front. X equals -3 plus or minus 3 times the square root of 2. All right, now I want to solve this by completing the square. Remember we discussed completing the square last time, and I showed you how to complete the square on the same side. When it's an equation like this, it's easier to do it by moving the term to the other side. So I'd have x squared minus 6x equals -2. Subtract 2 to the other side. Now remember, our first step is to make sure the coefficient of x squared is a positive 1. In this case it is. So our b term is this -6 divided in half. And then square that result. So I'm going to add 9 to both sides of the equation. So x squared minus 6x plus 9 equals -2 plus 9. Now this, remember, always factors into the perfect squares, x plus your b over 2 term. So x minus 3 squared equals -2 plus 9 is 7. So square root both sides, we get x minus 3 equals plus or minus the square root of 7. Add the 3 to the other side. Again, these are not like terms, so it goes in front. X equals 3 plus or minus the square root of 7. Let's solve this one by completing the square. Now notice this is already on the other side of the equation. So the first thing I'm going to do is divide by 4 so that the coefficient of the x squared is a 1. So if I divide every term in the equation by 4, I get x squared plus 6 over 4 reduces to 3 halves x minus equals 3/4. All right, now my b term is 3 halves. So if I divide that by 2, I get 3/4. So when I square that, square the numerator and square the denominator, you get 9 over 16. So I'm adding that to both sides of the equation. So I would have x squared plus 3 halves x plus 9 over 16 equals 3/4 plus 9 over 16. Now this, remember, always factors into x plus your b over 2 term squared. So this is x plus 3/4 squared. Notice when I'm working with fractions and decimals, it's much easier to remember that rule than it is to actually do the factoring. To add these two together, I need a common denominator. So I'm going to multiply this fraction by 4 over 4 to get a like denominator. 12 over 16 plus 9 over 16. So I would have x plus 3/4 squared equals, that would be 21 over 16. Now square root both sides. X plus 3/4 equals plus or minus the square root of 21 over 16, which we can simplify. And at the same time, I'm going to take the 3/4 to the other side. So I'd have x equals negative 3/4 plus or minus. Square root of 21 is 3 times 7, so I can't simplify that. Leave it as square root of 21, but the square root of 16 is 4. So there's my final answer. Now, what we did is we completed the square on a quadratic. If I do that same thing with the general terms ax squared plus bx plus c, we end up with this solution down here for x. This is the quadratic formula. If you don't already have it memorized, you need to memorize x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. I can plug in here to get a solution for x. All right, so with that quadratic formula, the stuff underneath the square root is called the discriminant. If what's under here is negative, I'll have two imaginary solutions, no real. If what's under here equals 0, I'll have one real solution. And if what's under here is positive, then I'll have two real solutions to my quadratic. Let's solve this using the quadratic formula. So the first thing that we do is put it in the right form. X squared plus 3x minus 5 equals 0. My a is a 1, my b is a 3, and the c is a negative 5. So filling into that quadratic formula, I'd have x equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. So that would be negative 3 plus or minus the square root of 9 plus 4 times 5 is 20, all over 2. So that would be negative 3 plus or minus the square root of 29, all over 2. All right, let's solve this one using the quadratic formula. So my a is 2, my b is a negative 3, and the c is a 7. So I would have x equals negative b, so negative 3, plus or minus the square root of negative 3 squared. Notice I put that whole thing in parentheses, minus 4 times a times c, all over 2 times a. So negative would be a positive 3 plus or minus the square root of negative 3 times negative 3 is a positive 9, minus 8 times 7 is 56, all over 4. So that's 3 plus or minus. 9 minus 56 is negative 47. Well, we know that a negative under the radical, we make that an imaginary number. So I'd have positive 3 plus or minus I times the square root of 47 all over 4. If 47 could be reduced, I would reduce that, but it can't be. All right, so now let's talk about the graphical interpretations of quadratic equations and inequalities. And what we'll do is we'll pick up here in the next video.